Good evening, everyone. Shall we start the session?
Good evening.
Good evening, Tejashwini. Good evening, Rahul. Fine.
Good evening,
So,
ma'am.
good evening. Good evening, Kana. Good evening, Varsha. Fine. So, let us start the class. Okay. Last class, I've given you two activities. Right. What are they? I've given you two activities. One is I've asked you to find the density of water. Another activity is I've given you a problem to solve, which is related to limiting rate. Right. And I think I've seen one solution in a WhatsApp group. May I know who shared it? I've seen one student shared a solution for that problem. May I know who's that?
Ma'am, it's me, Tatvatika.
Very good, Tatvatika. Answer was perfect. Very good, Kana. Anyways, we'll be discussing that problem here. But very good, Tatvatika.
Thank you, ma'am.
Fine. So we'll discuss the first activity. Okay. What is the density of water? Can you guys see the screen? Is it visible?
Yes, ma'am.
Okay.
One, ma'am, density.
One is just a number. Whenever you're telling something, you have to express it in units, right?
A gram per centimeter cube. 1 gram per centimeter cube.
Okay, 1 gram per centimeter cube. Okay, fine. We'll see, Akshaya. Actually, the answer was partially right. Okay, we'll see the density of water now. Actually, the exact density of water is 998.2 kilogram per meter cube. Okay, so actually what this mean, if I take 1 meter cube of water, then that weighs 998.2 kilogram. Approximately I'm taking this 998.2 gram as 1000. Okay, so 1 meter cube of water weighs 1000 kilogram of water. Okay, now I'm converting this kilogram into gram. How to convert that? 1 meter cube is equal to, I'm going to write the quantity of kilo as, what is the quantity of kilo?
10 cube, ma'am.
Very good, 10 power 3 gram. So again, I'm converting this meter cube into liter. What is the relationship between meter cube and liter? 1 liter is equal to 10 power minus 3 meter cube, or 1 meter cube is equal to 1 by 10 power minus 3 liters, right? Or 10 power 3 liter is equal to 1 meter cube. Am I right?
Yes, ma'am.
Yes. So instead of this 1 meter cube, I can write it as 10 power 3 liter, which is equal to 1000 into 10 power 3 gram. Now I'm going to convert this liter into milliliter. How to convert liter into milliliter? I'm just writing this 10 power 3 as such, and I'm going to write the unit to which I have to convert. To which I have to convert to milliliter, right? So 10 power 3 milliliter, and I'm going to write the quantity of milli in the denominator. What is the quantity of milli? Yes, what is the quantity of milli?
10 to the power minus 3, ma'am.
Very good, it is 10 power minus 3, which is equal to 1000 into 10 power 3 gram. Now I'm going to take this 10 power minus 3 to the numerator. So 10 power 3 into 10 power 3 milliliter, which is equal to 10 power 6 gram, or I can write it as 10 power 6 milliliter is equal to 10 power 6 gram. 10 power 6, 10 power 6 will get cancelled out. So what is the relationship? 1 ml is equal to 1 gram. So what does relationship mean? If you take 1 ml of water, that weighs 1 gram. Okay, and this relationship is applicable only to water and not to any other liquid, because the density of water is 998.2 kilogram per meter cube. But for every liquid, density may vary. So this relationship is applicable only to water. Okay. And this exact relationship I've used in some other problem, right? So that is why I've given you the activity. You guys got my point? Why I've used 1 ml is equal to 1 gram in that particular problem? Fine.
Yes, ma'am.
Fine. Please remember, guys, this relationship is applicable only to water and not to any other liquids. Okay, fine. Next, we'll move on to the activity problem. Have you guys done the activity problem? Tatvatika shared her solution. How about rest of the students?
I did not attend the last class, ma'am.
Okay, fine. How about Tejashwini? Okay, fine. We'll see the solution for that problem, okay? So here's the problem. How many moles of lead to chloride will be formed from a reaction between 6.5 gram of lead oxide and 3.2 gram of HCl? And the data given is atomic weight of lead is 207.2 gram per mole. Fine. Basically, we know that this problem is related to limiting reagent, right? See, whenever you're provided with the process, please write the equation to the process and make sure you're writing the balanced equation. Okay. So what is the process here? Lead oxide is reacting with HCl to give lead to chloride, right? So we'll write the equation for this given process. So what are all the reactants? Lead oxide is one of my reactants, is reacting with HCl to give what is the product? What is the product?
Lead to chloride, ma'am.
Very good. Lead to chloride is the product. But what is the formula?
PbCl2, ma'am.
Very good. PbCl2. So how to find this formula? See, in this compound, we have two elements. One is lead, another one is chloride. And obviously, the oxidation state of chloride is -1. And what is the oxidation state of lead? It is +2. So to find the formula of that compound, you have to put bracket here and write 1. Put bracket here and write 1. Multiply these two numbers. So Pb 1 into 1 is 1. Cl 1 into 2 is 2. So what is the formula? PbCl2. Okay. So whenever you're writing the equation, please make sure you're writing the balanced equation. Let us check whether this reaction is or whether this equation is balanced. Left side I have 1 lead and right side also I have 1 lead. So as far as lead is concerned, it is balanced. How about chlorine? Is it balanced?
No, ma'am.
No. Left side I have only 1 chloride, but right side I have 2 chlorides. So I have to add 1 more chloride to this reactant side. So now lead is balanced, Cl is also balanced. But left side I have 2 moles of hydrogen and 1 mole of oxygen. So 2 moles of hydrogen and 1 mole of oxygen, I'm writing it as H2O in the product side. That's it. Now I've written the balanced equation. So from the balanced equation, we have to come up with the inference. What is the inference? Inference has to be in terms of number of moles, right? So what is the inference? 1 mole of lead oxide is reacting with 2 moles of HCl to give 1 mole of lead chloride and 1 mole of water. Basically, what should be our inference? The quantity of hydrochloric acid required is twice the quantity of lead oxide, right? Or the quantity of lead oxide reacted will give the same quantity of lead chloride, something like that. Or the quantity of lead chloride formed will be half the quantity of HCl. These are all the inferences we can make from this balanced equation, right? Okay. So I've written the balanced equation, and from the balanced equation, I came up with the inference. Now I have to write the data. What are all the data given? They've taken 6.5 gram of lead oxide and 3.2 gram of HCl. Okay, and they're asking us to calculate how many moles of lead chloride is formed. See, whenever you're seeing the data, please make sure you're writing the number of moles of data. But here we are provided with weight. You have to convert this weight into number of moles. Have to convert weight into number of moles. Last class we have seen formula, no? Number of mole is equal to given mass divided by molar mass, or number of mole is equal to given mass divided by molar mass. It can be small m or it can be W. Anything is fine. So a number of moles to be calculated, and given mass of lead oxide is 6.5. And what is the molar mass of lead oxide? Please calculate and please let me know. What is the molar mass of lead oxide? Atomic weight of lead is 207.2 and atomic weight of oxygen is 16. So what is the molar mass of lead oxide?
223.2, ma'am.
223.2. Perfect. So 223.2. So by dividing these two numbers, we'll know the number of moles of lead oxide. Please divide and please let me know the number of moles of lead oxide. 6.5 divided by 223.2.
We are getting
Yes.
0.02 something, ma'am.
Yes, approximately 0.02. Okay. Fine. How about HCl? Given mass is 3.2. Molar mass of HCl is, atomic mass of hydrogen is 1, and atomic mass of chlorine is 35.15. 35.45. So what is the molar mass? It is 36.45, right? So what is the number of moles of HCl taken? 3.2 divided by 36.45.
Ma'am, 0.0808.
Something, ma'am.
0.08. Okay. Basically, we have to see which is the limiting reagent. What is limiting reagent? Limiting reagent is something whose quantity is less than the actual quantity required, right? See, the inference is what we came up with. Hydrochloric acid's quantity must be twice the quantity of lead oxide, right? So the lead oxide they have taken is 0.02, and what is its twice the quantity? It is 0.04. So HCl is an excess. Okay, so we have no problem with hydrochloric acid. How about lead oxide? Actually, lead oxide must be half the quantity of HCl. So HCl is 0.08. What is its half of its quantity? It is 0.04. But we have only 0.02. So which is the limiting reagent here?
Lead oxide, ma'am.
Very good. So basically, limiting reagent will decide the quantity of product formed. So whenever you are provided with the process, please write the balanced equation. And from the balanced equation, you have to come up with the inference. And after the inference, you have to write the data in terms of number of moles, and you have to check for limiting reagent. And from the limiting reagent, you can always calculate the quantity of product formed. So we know that lead oxide, if number of moles of lead oxide is 1, then number of moles of lead chloride is also 1, right? But here the number of mole of lead oxide is 0.02. So what will be the number of moles of lead chloride? Should be same, right? 0.02. So what will be the answer? What will be the answer?
Option D, ma'am.
Option D, that's it. Is that clear? Any doubt?
Madam, 1 minute, madam.
Yes, sir.
I just wanted to check with our Parli students, Varsha, Sudhir, and one more person has come. I think, what is his name? Um, I don't know his name. So, are you with us, Varsha and Sudhir? Are you able to understand?
Yes, sir.
If you don't understand, you just stop us. Stop our teachers. They are all willing to help you. Okay, I don't want you to sit with lot of doubts. If you don't understand, you just switch on your mic and then talk. Okay. Maybe
Okay, sir.
initial 1 or 2 classes you will find it difficult, but once 1 or 2 weeks are over, then you will find it very smooth. Okay, Varsha, Sudhir, what about you? Oh, okay, madam. Go ahead, madam.
Okay, sir. Okay. And the answer is 0.029. So the right answer is option D. Fine. And I think this is the solution Tatvatika posted in the group, and her answer was perfect, 0.029 mole. Okay, very good, Tatvatika. Fine. Now we'll move on to a few more questions. Okay. Last class, we have discussed concepts from or the problems from mole concept, and we have seen problems from atomic weight, molecular weight, and all. And this class we'll be discussing questions from empirical formula, molecular formula, and concentration terms. Okay. Apart from that, we'll be discussing questions from previous year NEET and JEE. Okay. So we'll see this question. This question is related to empirical formula and molecular formula. Okay. A compound contains 4.07% hydrogen, 24.27% carbon, and 71.65% chlorine. That is an organic compound, it seems, and that organic compound contains carbon, hydrogen, and chlorine. Okay. And they have given the molar mass of that compound is 98.96 gram, and they're asking us to calculate its empirical formula and molecular formula. Basically, what is molecular formula and empirical formula? What is molecular formula, first of all? What is molecular formula? See, for example, what is this?
Benzene.
What is this? Benzene.
Benzene.
So, in this compound, we have 6 carbons and 6 hydrogens, right? So, molecular formula is nothing but in this formula, we'll be writing what are all the elements present, and we'll be writing number of elements also, right? So, in this compound, we have 6 carbons and 6 hydrogens. So, this is the molecular formula of benzene. But empirical formula is little different from molecular formula. Empirical formula is nothing but that is the simplest formula of the compound in which we'll be writing the in which we'll be writing the elements, and to the subscript of the element we'll be writing its least whole number. See, according to benzene, the molecular formula is C6H6. Okay, let us write the empirical formula to this benzene. So, in this benzene, we have carbon and hydrogen, and we have 6 carbons and 6 hydrogens. So, we can divide these two numbers by 6, right, to get the whole number, least whole number. So, C1H1 is the empirical formula of benzene. Okay. So, in molecular formula, we'll be writing the elements present, and we'll be writing the exact number of elements present. But empirical formula is nothing but we'll be writing the simplest formula in which we'll be writing the least whole number to the elements present, right? So, according to benzene, C6H6 is the molecular formula, and C1H1 is the empirical formula. Fine, as simple as that. So, in this question, they are telling us there is an organic compound in which there are carbon, hydrogen, and chlorine, and they are telling that the molecular mass of that compound is 98.96, and from this data they are asking us to calculate empirical formula and molecular formula. Okay, so first we'll calculate the empirical formula, and after which we can calculate molecular formula. Okay, fine. So how to calculate empirical formula? Yes, Tejashwini's answer was right. Very good, Tejashwini. So in this organic compound, what are all the elements present? Carbon, hydrogen, and chlorine. So what is the percentage of carbon present?
24.27.
Very good, 24.27. And what is the percentage of hydrogen? It is 4.07. And what is the percentage of chlorine? It is 71.65. In next column, we have to write this percentage in gram. That's it. So if I take 100 gram of this organic compound, for that 100 gram, carbon will contribute 24.27 gram, and hydrogen will contribute 4.07 gram, and chlorine will contribute 71.65 gram. So in first column, we'll be writing what are all the elements present, and in second column, we'll be writing the percentage, and in third column, we'll be writing it or we'll be expressing it in gram. In fourth column, we have to express this weight in terms of number of moles. How to do that? What is the formula to convert weight into number of moles? Number of mole is equal to given mass divided by molar mass. Here, given mass of carbon is 24.27. And what is the molar mass of carbon?
It's 12, ma'am.
12, that's it. What is the given mass of hydrogen here? 4.07. And atomic mass of hydrogen is
1, ma'am.
1. Given mass of chlorine is 71.65, and the molar mass of chlorine is?
It is approximately 35.5, ma'am.
That's it. So you have to divide all these three, and you have to come up with number of moles of all these three elements. You just tell me the approximate value, that's enough.
2.2.
Yes. Approximately, I'm writing it as 2. And how about hydrogen? It is 4. 4 point something. I'm writing it as 4. And for chlorine, it is 2. That's it. Fine. So among these three, which is the least value? 2, right? So we have to divide all these number with least value. So among 2, 4 and 2, the least number is 2. So we have to divide all these number by 2. So 2 by 2 is 1. 4 by 2 is 1. 4 by 2 is 2. And 2 by 2 is again 1. So this is the least whole number of carbon. This is the least whole number of hydrogen. And this is the least whole number of chlorine. That's it. So what is the empirical formula? In this compound, I have carbon, hydrogen, chlorine. And for carbon, the least whole number is 1. Hydrogen, the least whole number is 2. And for chlorine, the least whole number is 1. So this is the empirical formula of this compound. Okay. So now we found the empirical formula of this organic compound. Next, we have to find the molecular formula of this compound. So basically, how to find molecular formula? Basically, molecular formula is nothing but molecular formula is equal to empirical formula of n times. So basically, we have to find the value of n, right? So for example, in this benzene, what is the molecular formula? Empirical formula into n times. What is the empirical formula? Which is C1H1. What must be the value of n? Here it is 6. So something like that. Here also you have to find the value of n to find the molecular formula. So to find the value of n, there is a relationship or a formula which is molar mass divided by empirical formula mass. So n is equal to, what is the molar mass of this compound? Which is 98.96. And what is the empirical formula mass? Here we have empirical formula from which we can calculate empirical formula mass. So here we have only one carbon and atomic weight of carbon is 12. Hydrogen, we have 2 hydrogens and atomic weight of hydrogen is again 1. And atomic weight 0.5. So 1 into 12 is 12, 2 into 1 is 2, and this is 35.5. So you just tell me what is the empirical formula mass of this compound?
39.5. 49.5.
49.5. Approximately, what is the value of n? Approximately, just tell me the value. Sorry? Sorry, Kana. 2. It is 2. So approximately the value is 2. So what will be the molecular formula of this compound? Empirical formula C1H2Cl1 and the value of n is 2. So molecular formula will be C2H4Cl2. That's it. Is that clear? Is that clear?
Yes, ma'am.
Right. So from the given data, we found what is the empirical formula and we have found what is the molecular formula of that compound. Fine. That's it. Now we'll move on to next concept, which is concentration. Okay. Are you guys familiar with this concentration concepts? Solution, concentration, and all that? You guys are familiar with that? Yes. Tejashwini is okay. How about Varsha?
No, ma'am.
Okay, you're not familiar. Okay, fine. How about Tatvatika?
Ma'am, it will be better if you explain.
Okay, fine. Right. So before getting into concentration, we have to know what is solution. See, in 12th standard, we have specific chapter called solution, where we'll be discussing in detail. Okay, but in 11th standard, we'll be touching few concentration parameters. Okay, but in depth we'll be discussing it in 12th standard. Okay, you guys, you should not worry about that. But basically, we'll see what is concentration. I mean, we'll see what is solution, what is concentration, and what are all the concentration terms. Okay, you just tell me what is solution.
It contains solute and solvent, ma'am.
Yes, definitely. Solution is nothing but that is something which contains solute and solvent. Okay, what else? Yes, fine. Yes, Akshaya.
Solute is the component of the solution that's present in larger amount. Solvent is a component of the solution that's present in larger amount,
Yes.
and solute is in small amount.
Fine, right. Okay. I have a beaker of water. Okay, will you call that as a solution? I have a beaker of water. This is not solution, right? To this beaker of water, I'm adding sodium chloride. Will you call this as a solution?
Yes.
Yes, ma'am.
Yes. I have beaker of water to which I'm adding 2 tablespoons of coconut oil. Will you call that as a solution?
No, ma'am.
No, ma'am.
No. So basically, what is solution then? Solution is yes, Akshaya, come on.
When solute molecules are thoroughly dispersed in amidst the solvent
Very good,
molecules.
very
it's a
good. So technically, it is called as homogeneity. So homogeneous mixture of 2 or more components is called solution. So basically, solution is not a pure one. It is basically a mixture, but that mixture must be a homogeneous one. So homogeneous mixture of 2 or more components is called solution. Okay. But in 11th and 12th, we'll be discussing only binary solution. What is binary solution? A solution in which we'll be having one or two components. That is called binary solution. Okay. And in a solution, the component whose quantity is very much high, then that is called solvent. And in the solution whose component is very much less, then that is called solute. Okay, so solute plus solvent gives solution. In binary solution, we'll be having only one solute and one solvent, obviously. But if the solution is not binary, for example, ternary solution, then we'll be having one solvent and we'll be having two solute. But in 11th and 12th standard, we'll be discussing only binary solution where we'll be having one solute and only one solvent. Okay, is that clear? Is that clear?
Yes, ma'am.
Yes.
Fine. Okay. Now we'll move on to the term concentration. Concentration is a way of expressing the quantity of the solute which is present in the solution. So concentration is something from which we can understand how much quantity of solute is present in the solution. Okay, but in chemistry we have so many terms to express this concentration. You would have familiar with the terms called molarity, molality. You guys familiar with these terms now?
Yes, ma'am.
Normality, mole fraction. Apart from this, is there any other concentration terms? No, you know? Molarity, molality, normality, mole fraction, ppm, mass percentage, volume percentage. These are all different concentration terms which we'll be using it in 12th standard. Okay, but in 11th standard syllabus, they've given only 3 parameters or 4 parameters: molarity, molality, normality, and mole fraction. And we'll move on to problems. Okay, fine. So whenever you're expressing the concentration, the expression will be like fraction. Okay, in numerator, we'll write the quantity of the solute, and in denominator we'll be writing the quantity of the solution or quantity of the solvent. Basically, what is concentration? Quantity of the solute which is present in quantity of the solution, or the quantity of the solute which we are adding in a particular quantity of solvent. So this is the way of expressing concentration. Okay, all these molarity, normality, mole fraction, all these terms basically will have this fraction. Okay, but what is the basic difference between these molality and all is the way of expressing the quantity may vary. So quantity can be expressed in terms of number of moles, or quantity can be expressed in terms of weight, quantity can be expressed in terms of volume. Okay, so based on the way of expressing the quantity, we are labeling it as molarity, normality, mole fraction, and all that. Is that clear?
Yes.
Fine. Now we'll see the formula of molality, normality, and mole fraction. Okay, first is molarity. Usually we'll be representing this molarity using a capital M. Okay, and formula of this molarity is, in numerator what we'll be writing? The quantity of solute. Here the quantity is expressed in terms of number of moles, and the alphabet what I'm using here is small n. And in numerator, the quantity of solute, right? So number of moles of solute divided by, in denominator we'll be writing the quantity of the solution, right? So here the quantity is expressed in terms of volume. So molarity is nothing but quantity of solute, number of moles of solute which is present in the volume of the solution. Here volume should be expressed in terms of liter. See, whenever you are writing number of moles, you have to express it in we have to express it in an alphabet small n, and to the subscript I can write two numbers. I can write 1 or I can write 2. 1 represents that parameter is representing solvent. Whenever I'm writing 2 in the subscript, then that represent I'm writing the quantity of solute. See, number of moles represents, small n represents number of moles, and in subscript I've written 2. So whose number of moles is that? Number of moles of solute. I've written just V. V represents volume, and in that subscript I didn't write anything. So what that means? That is volume of the solution. So in subscript, if I write 1, then that represents solvent. In subscript, if I write 2, then that represents solute. If I didn't write anything, then that parameter represents solution. So molarity is nothing but number of moles of solute which is present in 1 liter of the solution. That's it. Okay. Then we'll move on to molality. Molality has to be small m, which is equal to. Do you know the formula of molality? Yes, please tell me.
Number of moles of solute by mass of the solvent in kilogram.
Number of moles of solute divided by weight of the solvent in kilogram. That's it. So here I've written W, which represents weight, and subscript I've written 1 that represents weight of the solvent. Here weight should be expressed in terms of kilogram, and in molarity volume has to be expressed in liters. That's it. And how about normality? Normality is capital N, and the formula is number of gram equivalents of solute divided by volume of the solution in liters. Actually, what is number of moles of solute? May I know the formula of number of moles of solute? What is the number of moles of solute? I'm just asking the formula of number of moles. That's it. Number of weight of the divided by molar mass of the equivalence of solute is nothing but weight of the solute divided by equivalent weight of the solute. If it is weight by molecular weight, then that represents number of moles. If it is weight by equivalent weight, then that represents number of gram equivalents. As simple as that. Okay. So we have seen the formula of molarity, molality, normality, and finally mole fraction. How should I express mole fraction? What alphabet I should write? What alphabet I should use?
X1.
Very good, it is X. Okay. For example, a solution contains 2 components, X and A and B. Okay. For all the components, I can write mole fraction. Okay. For example, a solution contains 2 components, which is A and B. The quantity of A present is Na, that is number of moles of A is Na, and the number of moles of B is Nb. Okay. So I have 2 components, and for both the components, I'm going to write fraction. So mole fraction of A can be written as XA, which is equal to, the formula is, in numerator you'll be writing solute, right? So here for numerator I have to write A. So number of moles of A divided by total number of moles, which is number of moles of A plus number of moles of B. Similarly, what is the mole fraction of B? Mole fraction of A is number of moles of A divided by number of moles of A plus number of moles B. So what is the mole fraction of B? Now, numerator should be
Number of moles of B by number of
moles of A plus number of moles of B. That's it. Okay. So, if the solution contains 2 components, I can write mole fraction for both the components. And if I add both the mole fraction, what we get? By adding both the mole fraction, what we get? Just calculate and tell me.
it equals to 1
Very good, very good. For example, if a solution contains 3 components, then I can write mole fraction for all the 3 components. If I add the mole fraction of all the 3 components, again we'll get the value as 1. Is that clear? Is that clear? Fine. Okay, guys. Now we'll move on to problems now. Calculate the molarity of a solution prepared by dissolving 3 moles of solute in 500 ml of solution. They're asking us to calculate the molarity, and they're provided with the number of moles and volume of the solution. You just calculate and tell me the number of moles of solution. It is basic substitution, that's it. What is the answer? Varsha, what is the answer, Varsha? Okay. In this problem, they're asking us to calculate molarity. What is the formula to calculate molarity? What is the formula of molarity? Molarity is nothing but number of moles of solute divided by volume of the solution in liters. Right? What is the number of moles of solute? Okay, we'll see Tatvatika. Okay. What is the number of moles of solute?
It's 3 moles, ma'am.
Ma'am, is the answer 6 moles, ma'am?
We'll see, Kana. What is the volume of the solution? It is 500 ml, but we have to express the volume in liters, right? So 500 ml can be written as, it is 500 milliliter. Milli can be written as 10 power minus 3 liter. That's it. So by simplifying these stuff, we'll get the value of molarity. So answer is option A. Is that clear? Okay, Tatvatika and Tejashwini's answer were right. Yes. Right. Next, we'll move on to next question. Calculate the weight of solute dissolved to prepare 30 ml of 5 molar sodium hydroxide solution. This question is also from molarity, but here they're asking us to calculate the weight of solute and we are provided with the volume of the solution and concentration of the solution. Okay, the same formula, but we have to calculate weight of the solute. So what is the formula? Molarity is equal to number of moles of solute divided by volume of the solution in liters. Here they're asking us.
D, ma'am.
Sorry, Kana?
Option D.
Is it 6 gram, right?
No, ma'am. Option D.
0.2 gram. Okay, we'll see, Akshaya. So they're asking us to calculate the weight of solute. So number of moles of solute can be written as weight by molecular weight into volume of the solution in liters, right? Okay. So now I'm going to substitute the data. What is the molarity? 5, right? So 5. What is molarity? What is the unit of molarity basically? In numerator we have mole and in denominator we have liter. So the unit of molarity is mole per liter. So 5 molarity can be written as 5 mole per liter. So left side I have 5 mole per liter, which is equal to weight of the solute to be calculated. And what is the molecular weight of solute? The solute what they are talking about is sodium hydroxide. You just please let me know the molar mass of sodium hydroxide. What is the molar mass of sodium hydroxide?
40, ma'am.
40. Okay. Because we have only one sodium whose atomic weight is 23. We have only one oxygen whose atomic weight is 16. And we have only one hydrogen whose atomic weight is 1. So 23, 16 and 1. Right. So answer is 40. Right. So molar mass of sodium hydroxide is 40 gram per mole. And what is the volume of the solution? It is 30 ml, but we have to express it in terms of liters, right? So 30 into 10 power minus 3 liter. You just cross multiply these two stuffs. So W2 is equal to 5 mole per liter into 40 gram per mole into 30 into 10 power minus 3 liter. So common terms will get cancelled out. So per liter and liter will get cancelled out. Per mole and mole will get cancelled out. So by multiplying this, we'll get the answer in gram. You just multiply and tell me what is the weight of solute. So 5 into 40 can be written as 4 into 2 and 30 can be written as 3 into 10. I mean 40 can be written as 4 into 10 and 30 can be written as 3 into 10. So this 10 into 10 is 10 power 2 into 10 power minus 3. That's it. Now tell me the weight of solute.
6 grams, ma'am.
That's it. Is that clear? Any doubt? Any doubt?
No, ma'am.
Okay. Shall we move on to next question? Okay. Next question is, okay. What is the weight of sodium chloride required to prepare? What is this? What does this 5m represents?
Molality, ma'am.
Yes, it is molality because here the m is small m. So we have to read it as calculate the weight of sodium chloride required to prepare 5 molal solution by dissolving 50 gram of water. So here also we have to calculate weight of solute, which is W2. The data given is 5 molality, which is concentration, and weight of solvent. It is also direct substitution. If you guys are struggling, you just please let me know. I'll help you.
Ma'am, whether it is option B?
So you're telling me the answer is 14.6 gram, right?
Yes, ma'am.
We'll leave that with How about rest of the students? How about Marimuthu? Roshini? Akshaya, what is your answer?
Calculating, ma'am.
Okay. I'll give you 30 more seconds. Kundamilarasi,
I'm calculating.
what is your answer, Sana? Okay, okay. So what is the formula to calculate molality? Molality is equal to number of moles of solute divided by weight of the solvent in kilogram. and number of moles can be written as weight of the solute divided by molar mass of the solute into W1 in kilogram. And left side they have given the molality as 5. Right. And what is the unit of molality? Mole by kilogram. Right. So this is 5 mole per kg. Okay. So you can calculate the molecular weight of sodium chloride, and they are provided with the weight
It's
of
option B,
solvent
ma'am.
as 50. Option
B.
B, 14.6. So by substituting the data in this formula, we'll get the answer as 14.6 gram. Is that clear? Shall we move on to next question? Fine. So initially Tatvatika told me the answer as 14.6. Answer was right, Tatvatika. Okay, fine. We'll move on to next question. .3 gram of sodium carbonate, whose formula is Na2CO3, is dissolved in enough water to make 250 ml of solution. If sodium carbonate dissolves completely, molar concentration of sodium ion, which is Na plus, and carbonate ion CO3 2 minus are respectively. See, there is a salt called sodium carbonate. 25.3 gram of sodium carbonate was taken, and they are dissolving it in water, and they are preparing a solution of 250 ml. Okay, and they are not asking us to calculate the concentration of the solution. They are asking us to calculate the concentration of Na plus ion and CO3 2 minus ion in the solution. Basically, let's take only one molecule of sodium carbonate. Okay, in one molecule of sodium carbonate, how much Na plus and how much CO3 2 minus will be there?
1 each, ma'am.
No.
2 Na plus and 1.
Upon complete dissociation, we'll have Na plus ions and one CO3 2 minus ion. So in one molecule of sodium carbonate, we'll get 2 Na plus and 1 CO3 2 minus ion. So basically, there is a conventional way of calculating the concentration of NO2CO3. You have to find the concentration of sodium carbonate solution, from which you can calculate the concentration of Na plus, because the concentration of Na plus is to the quantity of sodium carbonate, and concentration of CO3 2 minus is the same quantity as Na2CO3, right? So by conventional way, you can calculate the concentration
Option
of
B.
sodium. Yes, concentration of sodium carbonate, from which we can calculate the concentration of Na plus and CO3 2 minus. But it is really lengthy. But the logic is, we know that the plus is CO3. Initially, first value represents the concentration of Na plus, and the second value represents the concentration of CO3 2 minus. And basically, what is the logic? The concentration of Na plus must be twice the quantity of CO3 2 minus, right? Of course, option D is wrong, because concentration of Na plus and concentration of CO3 2 minus seems to be equal, right? Which is not the case here. So, according to this option 2 is right. Is that clear? You need not calculate the concentration of Na2. You need not calculate the concentration of sodium carbonate and all. We can use this logic and we can come up with the answer. And who told me the answer? Who told me the
Ma'am,
answer?
myself,
Very good.
ma'am.
Very good, Kana. Fine. Is that clear? Shall we move on to next question? Next question is, calculate the volume of water to be added to 400 ml of semi-normal HCl solution to make it decinormal. Okay. See, basically in chemistry, we have two way of preparing solution. One method is, we'll be having salt, we'll be having solvent, we'll be taking particular quantity of salt and we'll dissolve in solvent to prepare a solution. That is one way of preparing. Another way of preparing solution is, will be having a highly concentrated solution itself. So from that stock solution, we'll be taking a particular quantity and we'll add water to it. Basically, we are adding water. Basically, we are diluting the solution to give another solution, right? So this question is basically the second category. Okay. So what they are telling, there is a solution called HCl solution whose concentration is semi-normal. What is semi? What is semi?
Than normal, ma'am.
Sorry, Akshay.
It's less than normal, ma'am.
Okay, kind of. Semi is basically half. Yes, Tatvatika is right. It is half. So what is half? It is 1 by 2. What is 1 by 2? It is 0.5. So HCl's concentration is 0.5 normality. Okay. So this is the stock solution they are talking about. So in the stock solution, they are taking 400 ml and they are adding water to prepare deci-normal solution. What is deci? What is deci?
It's 1/10.
1 by 10. Basically, it is 10 power minus 1 or 0.1 normal. That's it. Okay. So, for these kind of problems, we'll be using one formula. There is a formula called dilution formula. Usually, you'll be using this formula in lab where you'll be doing volumetric titration, right? In which you'll be
Ma'am,
using this formula. V1. Yes.
is it option C, ma'am?
We'll see. Very good, Kana. We'll see the answer. So there is a formula called V1N1, which is equal to V2N2. Here, V1 is the volume of the stock solution. Here, the concentration is expressed in normality, but you can express it in molarity also. And V2 is the volume of the resultant solution, and N2 is the normality of the resultant solution. Okay, fine. So here 400 ml is the volume of the stock solution, which is V1, and 0.5 N is the normality of the stock solution, which is N1. And to prepare deci-normal solution, so the resultant solution's concentration is 0.1 normal, which is N2. So from these data, we have to calculate V2. So basically, V1 is 400 ml and N1 is 0.5 normal, which is equal to V2 to be calculated, and normality of resultant solution is 0.1 normal. So what is V2? 400 ml into 5 into 10 power minus 1, which is equal, divided by 10 power minus 1. So what is V2? Hmm. 10 power minus 1, 10 power minus 1 will get cancelled out. So what is V2?
2000 milliliters.
Yes, 2000 milliliters. So from this, what we can infer is, initially there was a solution whose concentration was 0.5 normal, from which I've taken 400 ml. Okay. Now, I've diluted this solution, and the resultant solution's total volume was 2000 ml. And what was the question? Calculate the volume of water to be added to 400 ml of semi-normal solution. So, initially I had 400 ml. Now, the volume of the resultant solution is 2000 ml. So, how much water to be added to make this to 2000 ml?
1600 ml, ma'am.
That's it. So 1600 ml. So answer is option C. Okay. Is that clear? Initially, Poondamala receive was right. Very good, Kana. Fine. Shall we move on to next question?
Yes, ma'am.
Fine. Next, we'll move on to previous unique question. Okay. I'll read out this question. You guys try and please let me know the answer. An organic compound contains 78% by weight of carbon and remaining percentage of hydrogen. So seems to be hydrocarbon. The right option for the empirical formula of this compound is dash. They are asking us to calculate just the empirical formula. And in fact, they are provided with the atomic weight of carbon and hydrogen as well. Very simple.
Option C, ma'am.
Yes, it is option C. Guys, do you have any doubt? You want me to calculate? You want me to calculate? Poondamararasi? Tatvatika?
No, ma'am.
Do you have any doubt, Kanna?
No, ma'am.
Okay, fine. So shall we move on to the next question?
Yes, ma'am.
Okay, fine. So next question is, what mass of 95% pure calcium carbonate will be required to neutralize 50 ml of 0.5 molar HCl solution according to the following equation? Okay, they have given you the process and they have given equation. Okay, we'll understand the process first. There is a hydrochloric acid solution. Okay, the concentration of that hydrochloric acid is 0.5 molarity, and the quantity of that acid is 50 ml. Okay, basically that is a acid solution to which they are adding calcium carbonate. Basically, calcium carbonate is a base. So, if you treat hydrochloric acid with calcium carbonate, basically it is a neutralization reaction. That is the reaction they are talking about. So, I have this 50 ml of 0.5 molar HCl solution to which I am adding calcium carbonate to neutralize. So, they're asking us to calculate how much quantity or what mass of calcium carbonate is required to neutralize this much quantity of HCl. But the problem is calcium carbonate is not 100% pure, it is just 95% pure. Okay, so we have to calculate what mass of calcium carbonate is required to neutralize this 50 ml of 0.5 molar HCl solution. As I've told you already, whenever you're provided with the process, you have to write the equation. Here we are provided with the equation also, but we have to make sure that equation is a balanced one. Check whether this equation is a balanced one. Is it balanced?
No,
No, it is not. Fine. So let us balance this
it's not
equation.
balanced.
Please balance. Yes, it is not balanced, Kanna. Can you please balance and let me know? So you have to be very careful. So whenever you are provided with the equation, please make sure it is balanced or not. Okay. If you're balanced, please let me know.
Ma'am, is the answer is option C?
Okay, we'll see. Who told me the answer?
Ma'am, Poondamararasi.
Okay, Kanna. We'll see, Kanna. Fine. What is the balanced equation? Poondamararasi,
Yeah,
can you
ma'am.
please tell me the balanced equation?
CaCO3 plus 2 HCl gives CaCl2 plus CO2 plus H2O.
But that doesn't seems to be balanced, Poondamararasi. Because right side I have 4 moles of hydrogen, right? But left side I have only 2 moles of hydrogen. So that to be balanced, right?
Um,
Okay, we'll see.
okay, ma'am.
So how to balance this? Okay. Yes.
Since there is H2O on that side, we'll need 2 hydrogens, so 2 HCl.
Okay.
Carbon dioxide is liberated, so one more oxygen will be there that will constitute to the O in the H2O, so that will add up just fine. Since there is
Okay.
2 HCl, calcium chloride will automatically get balanced, ma'am.
Okay. So I'm writing the balanced equation here. Please check. Okay. Here in this equation, right side I have 4 moles of hydrogen, but left side I have only 2 moles of hydrogen. So to balance this, I have to write 4 moles. So 2 moles of, I'm writing the balanced equation, just check. Okay. So right side I have 2 moles of chlorine. Right side I have only, left side I have only 1 mole. So I can write it as 2 HCl, right? And how about hydrogen? Is it balanced? Hydrogen is balanced. How about oxygen? Left side I have 3 moles of oxygen, and right side I have 3 moles of oxygen. Right? Is it balanced?
Yes, ma'am.
Okay. So now this is the balanced equation. Okay. Now from this balanced equation, you have to come up with the inference. So what is the
Ma'am,
inference? Yes.
I too told this equation.
Oh, I'm sorry. I would have not listened. I'm really sorry, Pundamar.
It's
See,
okay, ma'am.
I didn't notice that what mole of H2O you told. Maybe I would have missed there. Okay. So, from what is the inference we can come up here? The inference is 1 mole of calcium carbonate is reacting with 2 moles of HCl to give 1 mole of calcium chloride, 1 mole of carbon dioxide, and 1 mole of H2O. Right? Okay. So basically, the inference is the quantity of hydrochloric acid required is twice the quantity of calcium carbonate. Is that clear? Is that clear?
Yes, ma'am.
Fine. So what was the quantity of hydrochloric acid taken? It is 50 ml of 0.5 molar HCl. See, they didn't give us the number of moles, but they have given the volume and the concentration. So from volume and concentration, we have to find number of moles. So what is the formula? Concentration is equal to number of moles by volume. So we have to calculate number of moles, and the concentration is 0.5. A molarity can be written as mole per liter, which is equal to number of moles divided by volume, which is 50 ml. So you have to cross multiply these two. So what we'll get? Number of mole is equal to 0.5 mole per liter into 50 milliliter, right? So liter and per liter will get cancelled out. So what is the number of moles? What is the number of moles?
25.
Is it 25? Is it 25, Kanna?
Yes, ma'am.
Okay, with unit. 25 is right, but I want it in unit. What is the unit? 25. I have this milli and I have this mole, right? So number of mole is 25 millimole, right? Is that clear?
Yes, ma'am.
Okay. So to neutralize this 25 millimole of HCl, what quantity of calcium carbonate required? According to this inference, what quantity of or what moles of calcium carbonate required?
1 mole, ma'am.
No. Actually, the inference is the calcium chloride required must be half the quantity of HCl, right? So here HCl is 25 millimole. So what quantity of calcium carbonate required? Half of this. It is not 1. You guys getting my point?
Yes, ma'am.
So, what quantity of calcium carbonate required to neutralize this 25 millimole of HCl? Yes, Pundamararasi. You guys getting my point? I'll repeat it. See, to neutralize 2 moles of HCl, we need 1 mole of calcium carbonate. Basically, calcium carbonate taken should be half the quantity of HCl, right? So here HCl's millimole is 25 millimole. So how much quantity of calcium carbonate required? Half the quantity of HCl, right? Yes, Pundamalarsi?
Ma'am, 14.5.
Half of 25 is 12.5. Okay. So Tejashwini and Tatvatika told the right answer. So half of 25 is 12.5, right? That's it. So calcium carbonate required is 12.5 millimole. Is that clear?
Yes, ma'am.
That's it. Okay. So, but the answer is in gram, but we found it in mole. So we have to convert this millimole to gram. So have to convert that. We have the formula, right? Number of mole is equal to given mass divided by molar mass. So number of mole is 25.5 millimole, which is equal to, we have to find the weight and we have to know the molar mass of calcium carbonate. What is the molar mass of calcium carbonate? Just calculate and tell me. What is the atomic mass of calcium? Atomic mass of calcium is 40. Carbon is 12. Hydrogen's atomic mass, oxygen's atomic mass is 16. So, a molar mass of calcium carbonate is 100. Okay. So, 100 gram per mole. Okay. So, just cross multiply these two numbers so that you'll get the weight of calcium carbonate required. So can be written as 12.5 into 10 power minus gram per mole. So mole and per mole will get cancelled out. So W is equal to 12.5 into 10 power minus 1 or W is equal to 1.25 gram. Okay. Fine. Till now, is that clear? This is not the final answer, but till now, is that clear?
Yes, ma'am.
Okay. So we can conclude that if my calcium carbonate is 100% pure, then I need 1.25 gram of calcium carbonate to neutralize this much quantity of HCl. But the problem is calcium carbonate is not 100% pure. It is just 95% pure. So what this mean actually? 1.25 gram of 95% pure calcium carbonate is not sufficient. I should have more than 1.25, right? Is that clear? I have to add more than 1.25 gram of calcium carbonate because it is not pure, because 5% impurity is there, right? So definitely answer is not second option. So basically there is a formula to calculate percentage purity of any component. I'll write it here. So percentage purity of, in this case, it is calcium carbonate, right? So percentage purity of calcium carbonate, which is equal to weight of pure calcium carbonate in a particular sample of calcium carbonate. So weight of sample of calcium carbonate. Okay. So here they told the purity is just 95%. So left side it is 95. It is, since it is percentage, 95 by 100, which is equal to weight of pure calcium carbonate required is 1.25. But how much sample of calcium carbonate required if the percentage, if the purity is just 95? We need to calculate. So you just calculate the value of X and let me know the answer.
Ma'am, 1.32.
Exactly, it is 1.32 gram. Is that clear?
Yes, ma'am.
That's it. Fine. Shall we move on to next question?
Yes, ma'am.
Okay. Okay. Here also the question is something related to purity. The right option for the mass of carbon dioxide produced by heating 20 gram of 20% pure limestone. Limestone is nothing but calcium carbonate. Okay. So they have given the process and the equation as well. Basically, the process is they are heating the calcium carbonate. So by heating, we are decomposing this calcium carbonate to give calcium oxide and carbon dioxide. Okay. They are not heating the pure calcium carbonate. It is just 20% pure. And they are asking us to calculate how much mass of carbon dioxide will form. You guys please try from your end. I'll give you 1 minute. So check whether the equation is balanced one, and you just come up with the inference, and you just calculate how much mass of carbon dioxide will evolve if you take 20 gram of 20% pure limestone. I'll give you 1 minute, okay? Okay, shall we do it together? If you guys working out, then I'll give you time.
Ma'am, 1.76 gram.
Okay, okay, Gana, we'll see. Okay, we'll do it together. So Undamirarasi's answer is 1.76 gram. We'll see. So calcium carbonate, upon decomposition, it gives calcium oxide and carbon dioxide. So I think this is a balanced equation. So what is the inference? If I take 1 mole of calcium carbonate, I'll end up with 1 mole of calcium oxide and 1 mole of carbon dioxide, right? See, what is the data given? They have taken 20 gram of calcium carbonate, but that is not 100% pure. That is just 20% pure. So from this, you have to calculate what is the exact quantity of calcium carbonate taken. Have to calculate that. We know the percentage purity formula, right? So percentage purity of calcium carbonate is equal to weight of pure calcium carbonate divided by weight of the sample. So weight of the sample is 20 gram, right? And weight of pure calcium carbonate to be calculated. And what is the percentage purity of calcium carbonate? It is 20%. So 20 divided by 100. So what is the actual quantity of calcium carbonate present in this 20 gram of limestone?
Ma'am, 1.76.
No. In this 20% pure limestone, I'm asking how much gram of pure calcium carbonate is present?
0.01.
Okay. We'll see, Kana. So from this, you just calculate the value of X.
Sorry, ma'am, 4.
Yes, it is 4 gram. Is that clear? So in 20 gram of 20% pure limestone, there is only 4 gram of pure calcium carbonate, right? So the data is they are decomposing only 4 gram of calcium carbonate. Whenever we have weight, we have to convert this weight into number of moles. So what is the formula to calculate number of moles from the given weight? Given weight is 4 gram and molar mass of calcium carbonate is 100 gram per mole, right? So what is the number of moles? What is the number of moles? 1 by 25, right? So 1 by 25 mole of calcium carbonate gives same quantity of carbon dioxide, which is 1 by 25 mole of carbon dioxide. But they're asking it in, or they're asking us to express it in weight or in gram. So number of mole of calcium carbonate, the number of mole of carbon dioxide evolved was 1 by 25 mole. So what is the weight of carbon dioxide evolved? So from number of moles, you have to calculate weight. So number of mole is equal to given mass divided by molar mass. So number of moles of carbon dioxide evolved was 1 by 25, and the weight of carbon dioxide evolved must be calculated divided by molar mass of carbon dioxide is molar mass of carbon dioxide is yes, it is 44. Satvatika told molar mass of carbon dioxide is 44 gram per mole. So you just calculate and tell me the weight of carbon dioxide evolved. So what is W? Poontamil Arasi told the answer was 1.76. How about rest of the students? Roshini? Okay, Tatvatika's answer is also 1.76. Yes. So the answer is option C. Is that clear? Is that clear? Okay, fine. Now, you just take this question as activity. Take this question as activity. Here, I'll read the question, okay? We'll understand the question and you can do it as your activity. So 20 gram of magnesium carbonate sample decomposes on heating to give carbon dioxide and magnesium oxide. Okay. What will be the percentage purity of magnesium carbonate in the sample? Here in this question, they're asking us to calculate the purity of the sample. Okay. And the process they have given is magnesium carbonate was taken, and by heating we decomposed this magnesium carbonate to give magnesium oxide and carbon dioxide. So I'm going to write the equation for this process. So what is the formula of magnesium carbonate? What is the formula of magnesium carbonate? Mg MgCO3. MgCO3. Yes. So upon decomposition, we'll get magnesium oxide and carbon dioxide. And we have to make sure this equation is balanced. Is it balanced? Yes, it is. Right. So they are telling like they have taken 20 gram of magnesium carbonate, and they are decomposed this magnesium carbonate and they got only 8 gram of magnesium oxide. And from this data, they're asking us to calculate the percentage purity. Okay. Is it possible for us to solve it? Is it possible for us to solve it? Or shall we solve together now? Okay. So what is the inference? Here, number of moles of magnesium carbonate is 1. So 1 mole of magnesium carbonate will give 1 mole of magnesium oxide and 1 mole of carbon dioxide, right? Here, they have taken 20 gram of magnesium carbonate. So the data is 20 gram of magnesium carbonate. Whenever we are provided with gram, then we have to convert that gram into number of moles. So if magnesium carbonate taken is 20 gram, then what is the number of moles of magnesium carbonate? The formula is number of moles is equal to weight by molecular weight, right? So number of mole is equal to given mass divided by molar mass of magnesium carbonate. What is the molar mass of magnesium carbonate? Magnesium is, in magnesium carbonate we have only 1 mole of magnesium whose atomic weight is 24, and magnesium carbonate we have only 1 mole of carbon whose atomic weight is 12, and magnesium carbonate we have 3 moles of oxygen whose atomic weight is 16. So what is the molar mass of magnesium carbonate?
Ma'am, 40.
No. No, Kanna? Yes, it is 84. Tatvatika's answer is right. It is 84. Right. So 20 divided by 84 gram per mole will give you the number of moles of magnesium carbonate. So you just calculate and tell me number of moles of magnesium carbonate. It is 20 divided by 84 gram per mole. Just tell me the approximate value. Approximately we'll get it as 0.23 something. What is the number of moles? 20 divided by 84. Approximately it is 0.23 mole. Okay. So if you decompose this if you decompose 0.23 mole of magnesium carbonate, then how much mole of magnesium oxide we will get? You'll get same 0.23 mole of magnesium oxide, right? So if the number of moles of magnesium oxide formed is 0.23, so what must be the gram of magnesium oxide formed? We have to use the same formula, right? Number of mole is equal to given mass divided by molar mass. So number of moles of magnesium oxide formed is 0.23, and weight of magnesium oxide formed to be calculated, and we have to calculate the magnesium oxide's molecular weight. So magnesium is 24 and oxygen is 16. So what is the molar mass of magnesium oxide? What is the weight of magnesium oxide? It is 40. That's it. So from which you can calculate the weight of magnesium oxide formed. So if you take 100% pure magnesium carbonate, then you'll get this much quantity of magnesium oxide. Can you please calculate and tell me how much gram of magnesium oxide will form? So you have to cross multiply this 0.2 and 40. Approximately? Approximately it is
8, ma'am.
8. You're multiplying 0.23 with 40, right?
Yes, ma'am.
No, it is not 8. 0.23 into 40. That is not 8. It is 9.2. It is 9.2. 40 into 0.23 is 9.2. Okay. So if you take 100% pure magnesium carbonate, then 20 gram of magnesium carbonate will give 9.2 gram of magnesium oxide. But according to this question, they have taken 20 gram of magnesium carbonate, but we got only 8 gram of magnesium oxide, which means magnesium carbonate is not 100% pure. Right? So actually, we need to get 9.2. But how much we got? Just 8. So what is the percentage? 8 by 92 into 100. 8 by 9.2 into 100. Approximately, approximately around 80, 85, 86 we'll get, because here we have taken approximate values, no? So exact answer is 84. But if you calculate from this data, you'll get 86%. Okay. According to this option, 84 is the right one. Okay, is that clear?
Ma'am, I have a doubt, ma'am.
Yes.
Ma'am, if we instead of taking 0.23, if we take 0.2, the answer is 84, ma'am. Accurate answer is 84, ma'am.
Definitely you can do. Definitely you can do. You have no issues. You can do.
Okay, ma'am.
But you got just 0.2 mole. How much mole of magnesium carbonate you got?
0.2 moles of magnesium oxide, ma'am.
Actually, they have taken magnesium carbonate as 20 gram, right? And what is the molar mass of magnesium carbonate? It is 84, right? So the exact answer is 0.238. It is not 0.2. Actually, the original number of moles of magnesium carbonate taken is 0.238. So you cannot round off to 0.2. Okay. Here, the options are wide enough, so you can take 0.2. But if the option is narrow, then you cannot do it. Kanna. Fine. Is there any other doubt? Akshaya?
No, ma'am.
Roshini? Maribu? Pundamedarsi? Tatvitika?
No, ma'am.
Shall we wind up the session? Okay. In next class, we'll be discussing questions from atomic structure, that is quantum mechanical model of an atom. So please make sure you have revised the chapter, and I want you guys to do all your exercise problems. Okay. If you guys are from state board, please try to solve your exercise problems in your state board book. If you guys are from CBSE, please try to solve your exercise problems from NCRT book. Okay. Fine. Shall we wind up the session?
Yes, ma'am.
Okay, guys. Okay.
Thank you.
Thank you. Okay. Bye, Kanava. Bye. Good night.
Thank you, ma'am.
சார் நான் கிளாஸ் க்ளோஸ் பண்ணிக்கிறேங்க சார். சார்